This is Tutorial, and today I discuss about a very important theorem which belongs to differential calculus. This is Hospital's rule. So it is very important rule to find out limits of many functions. So I just established first how Hospital rule are established in my own analysis. It is my own analysis through using Taylor's theorem. On analysis, just by on analysis, you will not get in any book. Very easier way I have find out to prove this. So must watch and share with your friends, and of course subscribe this channel. You are watching my videos but not subscribing this channel, so must subscribe this channel to get the videos at first. So let's start now. Yale Hospital's rule. This rule is very important. So just concentrate to understand. Very easy way I have found out to prove this. So you will not have any problem to understand this. First I will write the statement. What is the statement? The statement is that this one is very important and proof also. But proof is not for important for exams, but for your basic background of mathematics, you need to understand the proof. It is said that any limiting value of the quotient of two functions where x tends to a, then fx and gx where where both f0 fa is equal to and ga is equal to fa is equal to 0 and ga is equal to 0. Is if this happens, both are 0 by 0 in the form, then the limit cannot be calculated in the easy way. It will be equal to, by Hospital's statement, it will be equal to f dash first derivative of fx, if a if a, and first derivative of gx at the point a. When when first derivative of gx at the point a not equal to 0. If it happens, then the limiting value will be equal to this. And if it does not hold, then what is? Then also a L'Hospital rule can be explained. If g first derivative of g x at the point A is equal to 0, if it happens, then again we will take the limit. Again we will take the limit, and this will be equal to limit x tends to A. First derivative of x here, you will not put x equal to A, because now first derivative of a gx at the point A is equal to 0, so you will not put x equal to A. Just first derivative of x, first derivative of g is equal to second derivative of f at the point, second derivative of f at the point A, and second derivative of gx at the point A, where this is not equal to 0. And again, if the second derivative of g x at the point A is equal to 0, then again we will continue this procedure. So this is the L'Hospital's rule. How it can be proved? So let's see the proof. Proof. We will first use Taylor's theorem. We know by Taylor's theorem, by Taylor's theorem, this is just proving through my own analysis. You will not find it any textbook. So, so just sincerely watch this video and try to remember own analysis. You will not get it any, and it is true. This proof is true. You do not worry about this. My own analysis. So, by Taylor's theorem, we can expand both the fx and gx. Fx can be fx can be expanded in this way. Fa plus is by 1 factorial by f prime derivative of fx at the point A plus h square by 2 by 2 factorial, and second derivative of fx at the point A. And so you can continue this procedure plus dot dot dot. And in this way, which is h? Here h is equal to x minus a. Since x is tending to a, so h will be tending to 0. So it is a neighborhood expansion, very important neighborhood expansion. I believe it is the best theorem in differential calculus in my view, because any kind of complex problem in differential can be solved by Taylor's theorem. That's why I think it is the best theorem in the differential calculus, and I am using this again. Gx can be expanded the same way. Ga plus, you can take same h, or another one. You can take I mean same one, x and a is same, so I am taking h also. It does not matter. You can take another one, but it does not matter, h or k or anything tending to 0, so it does not matter. 1 factorial first derivative of g, sorry, first derivative of g at the point x, at the point a, and h square by 2 factorial by second derivative of a g at the point a, gx, second derivative of gx at the point a, so and so on. So now how will we use this? Now if we will calculate the limiting value of the two functions quotient, what will we get? Limit x tends to a, we have given fx by gx, and also given that it must be in the form 0 by 0, means both the functions at the point a will equal to 0 by 0. So if a is equal to 0, ga is equal to 0, then I expand both of them by Taylor's theorem. But what we will get? We will get in this way, if a plus is by 1 factorial by first derivative of fx at the point a plus h square by 2 factorial and second derivative of fx at the point a, and so on. You can continue this procedure if you desire. And in the denominator, the expansion will be ga, same way, g plus h by 1 factorial first derivative of gx at the point a plus h square by 2 factorial second derivative of gx at the point a, and so on. You can also carry this extension. So now if a and ga is equal to 0, if it happens, then what will be? If a is equal to 0 and ga is equal to 0, then what will be? It is clear that it will be that this will be 0, this term will be 0, and this term will be 0. No other terms will be 0 at the point, because just this function at the point are 0. So If we ignore, because h is very small, h is very small and tending to 0, so we just ignore the other terms. These terms are ignored, the other terms are ignored. Just you can just uh, cancelling h or r on the numerator and denominator, you will get the result. So in this way, you get the result. And if it happens that uh, this is fa0 ga0 and also if first derivative of a, again you are getting 0 by 0 form. Again you are getting, after doing this, again sorry, not a, x, again you are getting 0 by 0 form. This will be again 0 by 0 form. After doing derivative and differentiation, you are getting again 0 by 0 form. Then what will we do? You will put here 0 and you will put here 0. Then two terms vanishes. This two term and this two term vanishes. And what we will get? We will take the third term and again cancel. Again cancel. We will get what? We will take a limit here. Then what we will get? X tends to a. What we will get? Just cancelling h square by 2 factorial on both denominator and numerator. We will get second derivative of x at the point a and second derivative of g x at the point a. And if again we will get 0 by 0 form, then again we will put the value and take the next term and just cancelling that we will get the limiting value. So this is the proof of the Euler hospital theorem. I am giving one example. It will clear you more. Limit here x tends to 0, and the equation is given in this way. On the upper side you are getting x cube, and below you are getting 1 minus e to the power x. So you can very easily compare that this is your 0 by 0 form. If you will put x equal to 0, then you will get 0 by 0 form. Then what will we do? We will do the differentiation of both. And then first differentiation will get, and we will do it in the rough. So it will be 3x square, and in the below we will get uh, just minus e to the power x. I am putting here. Okay, e to the power x. So here you are getting I am putting this list. Also, this is also then you will here get 2 into 1 minus e to the power x, and there will be minus 1 also. Minus 1 also. 2 into 1 minus e to the power x minus e to the power x. So this will again get 0 by 0 form. So we will not put the limiting value. We cannot put because the denominator is 0 equal to 0. Again we are getting 0 by 0 form. So we will continue the differentiation procedure. So again x tends to 0 and we will now write the differentiation form. This will be 3x square and this will be minus 2 e to the power x, and here will be 1 minus e to the power x. So here again getting 0 by 0, then we have to do again the differentiation. Is also 0 by 0 form. So if we continue this procedure, we will get, again we will do in half first. In the numerator we will get 6x, and in the denominator what we will get, here we will get first if we multiply this, then we will get uh, minus 2 e to the power x. I have first multiplied and then doing this 2 e to the power 2x. So what will be its value? Now again it is 0 by 0 form. You can look, this is 0, and if you put here 0, then you will get, no, this is not 0 by 0 form. This is not 0 by 0 form. This is not 0 by 0 form. So we will get the value. So but now we will put the limiting value here. So what will be the limiting value? The limiting value will be 6 into 0 and minus 2 e to the power 0 is 1 and minus 2 again 1. So this will be 0. So this answer is 0. So here I applied L'Hospital's rule. I hope you like this video, and if you like this video then must comment me, share with your friends, and I just appeal to all of you, just must subscribe this channel. You are watching videos, must subscribe this channel, because if you subscribe then you will get all the uh, videos at first. So must subscribe. I hope you like this video. If you have any suggestion uh, to uh, on your own topic, if you want to watch uh, from me any video, then comment me and share with your friends. Comment me. I hope you liked. Thanks for watching. Have a good day.